Hello everyone, and welcome to your explanation for worksheet 2B. This is in week 3 of the college trig class, MAT122 here at Overland. This is Mr. Griesel, and I'm going to go over a few problems from this worksheet, and hopefully I do a good enough job explaining it that you understand it fully. So on this worksheet, what we're going to be doing is a bit more conversion from radians to degrees. With this, you may want to have your unit circle out, as some of these are going to be a little bit faster to just look off the unit circle and convert them that way. That's how they want you to do these first couple of problems, but that's your choice. So here we go. For the first ones, it says mentally convert the radian measures to the exact degree measures. So I'm looking at number 1 first. I showed all my work using the conversion chart or the conversion that I just had up on how to do these. But if you look at the unit circle, 3 pi divided by 2 is like 1.5 pi. So that's halfway around the circle plus another quarter, and that gives you 270 degrees. Once again, I showed my work if you weren't able to do that mentally here, and it's pretty straightforward on that one. Okay, pi is just half a circle in radians, so half a circle in degrees is just 180 degrees. And once again, I showed my work here in red if you weren't able to do that mentally. Now, half a pi, if half a trip around the circle is pi, then half of that half is a quarter of a circle, so that's 90 degrees. And I showed all my work for that conversion here in green. Looking at number 3, these are all in degrees, and now we need to switch them into radians. Well, 30 degrees is 1/6 of a pi. I used the formula to show how that you could get that in green here, but that's how I would do that mentally. 60 degrees is just double 30 degrees, so if you double a 1/6, you get 2/6, and that's a third, so pi divided by 3. I showed how to do that here in red with the formula or the conversion. And then 90 degrees is just like I said, a quarter of a trip around a circle, so that would just be half a pi, and that's how I got it here in blue. Okay, so the next section says find the degree measures of the 2 nearest angles, one positive, one negative, of that are coterminal of a given angle. Well, coterminal means you start at the same starting point, you end at the same ending point, but you're just doing it in a different way. So they give us 90 degrees. So typically we would start at a 0 and we would swing upwards till we get to 90 degrees, and that's what I have in black there. Well, another way to do that in blue is you start at that 0, you go all the way around the circle, and then you go up 90 degrees. So that would be a full trip around the circle, which is 360, plus the 90 it took us to get to that the 90 mark. And so we add those together and you get 450 degrees. And I did all of that in blue. Okay, the other way to do it is to go backwards or in the negative direction 360 degrees, and then from there swing up to our 90, and that's what I have in red. Okay, so to find that degree measure, it would be 90 minus 360, so we're going to get negative 270 degrees, and that'll get us back to that same ending point that we had in black. Okay, so for all of these, you're going to have a positive and a negative answer. Okay, now 5 through 7 are all in degrees, so they're pretty straightforward. The radians get a little trickier because you have to do some fraction work. So for number 8, we have 7 pi over 6. If we just swing that normal, it's going to go a little bit past the pi mark, 1/6 past that. So in black, I have what it looks like. And if drawing a picture helps you on these, feel free to draw a picture because I think it's helpful. Okay, then we did the blue one. So the blue one is doing a full trip around a circle plus the 7 pi over 6. So a full trip around the circle in radians is 2 pi, and we're adding that to our 7 pi over 6. Well, that's what I have over here in blue. It's 7 pi over 6 plus 2 pi. I need to make 2 pi a fraction, so I put it over 1. Then I need to make the bottom the same as the other fractions. I need to turn it into a 6. So I get 7 pi's plus 12 pi's, and that's 19 pi's over 6. And that is the blue one. Now to do the red one, we're going to do the exact opposite. We're going to go backwards 2 pi, so negative 2 pi, and then we're going to add that 7 pi over 6 to it. So 7 pi over 6 minus a 2 pi, so we're going to have a negative answer. Once again, make it a fraction by putting it over 1 and make the bottoms the same. So if you subtract that, you're going to get negative 5 pi over 6, and that's how you do those. So like I said, the radians are a bit more difficult because it's a lot more fraction work, and a lot of people hate fractions, but that's how we do it. Now, for number 13, well, the next set of problems, 11 to 16, you're going to be using the formulas. So for number 13, I had 108 in degrees, and I need to switch that into radians. So I multiply that times pi over 180. I get 108 pi over 180. And I just reduced both of those by I don't know what number I used. What did I divide it by? I think it was like 36, I believe. Yeah, I think it's 36. So if you divide both those by 36, you get 3 pi over 5. And I'm going to leave it in that form. I'm not going to turn it into a decimal unless I absolutely have to, because that answer is in exact form, so that's good. Let's look at number 16. This is in radians, so we're going to multiply it by 180 over pi, which is the exact opposite to the last problem. Pi's will cancel off from the top and bottom, so we're going to get 360 divided by 9, and 360 divided by 9 is just 40 degrees, and that worked out really nice. Okay. Number 17 through 19, those are all review. Look at worksheet 2A for those formulas, so that shouldn't be a too new of a thing. And then let's talk about number 22. It says we have an equilateral triangle and it has a height of 3 pi, or 3 times root 5. So remember, just like on worksheet 2A, we have some 30, 60, 90 stuff going on. So to go from the longer leg on a 30, 60, 90 triangle to the shorter leg, we are going to divide by the square root of 3, and that's what I've done over here to the right. Well, you can't have a radical on the bottom of your fraction, so we have to multiply by root 3 over root 3, which is the same as multiplying by 1. So on top, we're going to get 3 root 15 over, and then root 3 times root 3 is just 3. 3's cancel off. I'm left with root 15. So that's what that bottom leg is going to be. So the whole side, or the whole, if we're looking back at the equilateral triangle, we just found half of it. So we just double that. So 2 times root 15 is just 2 root 15. And then there's 3 sides on the triangle. So we multiply that times 3, and we get 6 root 15. And that is the total perimeter for the equilateral triangle. And that is it. Okay, so that is all of worksheet 2B that I'm going to do. Should you have any questions, feel free to email me and or bring them to class, and it should be good. The rest of the answer key is on Schoology, so use that as much as you need. All right, I'll talk to you later.